Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zulhazri bin Zakaria, AE190019. We present about the activity 3.3.1, which is the open loop position control. So this is the block diagram for open loop position control. First, we need to key in all parameter values into the simulating block. So this is the electrical part for the block diagram. The mechanical part, the shaft motor position, input voltage, input angle, potentiometer gain, and attenuator gain. Increase step-by-step value of input angle from 0 till 10 and set attenuator gain 0. Observe the shaft motor position display and what happened to the system. Okay, we set the attenuator gain to 0. Then they need to input angle increase step by step 0 till 10. So the shaft motor position will 0, input voltage 0.611. Then we increase the input angle, for example 5. Then the input voltage 3.056 will increase, but the shaft motor position will remain 0. Then we increase again like 7. So we see the input voltage will increase 4.278 and the shaft motor position will remain 0. For question 5, increase step by step value of attenuator gain from 0 till 10 and set input angle to 0. Then observe the shaft motor position display and what happened to the system. So we need to set the input angle to 0. The attenuator gain we increase step by step from 0 till 10. And we see the result. The input voltage is 0, shaft motor position 0. We set to 1. Then we see the result. Same, the input voltage 0, shaft motor position 0. Then we increase again to, for example, 8. Like we see the same, the input voltage is 0 and the shaft motor position is 0. Alright, for question 6, we need to input angle set to 5, 10 and 360, and positive for clockwise and negative for anti-clockwise. For when input angle is set to 5 and attenuator gain set to 1, we get the input voltage is 3.056 and shaft motor position 58.64. Then we fill into the table. For input angle for anti-clockwise, we need to negative 5. So the result of input voltage is negative 3.056 and shaft motor position negative 58.64. For input voltage, we fill to 10. The attenuator gain, the value is 5. Then we run the simulation. We get the input voltage 6.111 and the shaft motor position 586.4. For anti-clockwise, negative 10. So we get the answer is negative for the input voltage, negative 6.111, and shaft motor position we get negative 586.4. So we increase again the input angle 360. Alternate again, we set to 8 and we run. We get the input voltage 220 and the shaft motor position 30,680. For input angle anti-clockwise, so we get the result negative. Then we fill into the table. So for the average error percentage, we get 98.91%. Alright, that's all from me. Thank you.
Assalamualaikum, my name is Nohafiza binti Ali, metric number CE190089, and I will present for activity 3.3.2, the closed loop of position control. Here is the input angle. This is the position sensor input or the potential input gain, which is Kp 0.61111. And here is the sum. Here is the attenuator gain. This is the electrical part, 1 over 0.121, which is the electric inductance, plus 11.2, which is the RA, the electric resistance in ohm. And this is the mechanical part, 1 over 0.22, which is the Jm, moment of inertia of the motor, plus 0.003, which is Bm, motor versus friction constant, and 1 over S is the integrator. And here is the position sensor output or the potential meter output gain is 0.6111, which is Kp, same with the input. And here we will record the reading for input voltage, shaft motor position, and output voltage. First, we set the input angle to 1 and the alternator gain 1 to check whether this block diagram is function or not, and then we click run. Here is your input voltage reading, output voltage, and shaft motor position. This show that this block diagram is function. And then we will set the input angle to 0, and then we will increase it from 0 till 10, and then the internet again 0. Here show when the input angle and the alternator gain is 0, the input voltage, shaft motor position, and output voltage is 0. And then we will skip and to increase the input voltage to 10. And we can see that we have the reading for input voltage, however the shaft motor position and output voltage is 0. And then we will set the input angle to 0, and we will increase the alternator gain from 0 to 10. First we set the alternator gain 0, and we can see that the input voltage of motor position and output voltage does not have reading, which is 0. And then we will increase the alternator gain from 0 to 10, and we will skip to 10. angle is 0, alternator gain is 10. In the input angle 0, the input voltage, shaft motor position and output voltage does not have reading, which is 0. And then we will set input angle 5, 150, 360 for potentiometer positive for potentiometer clockwise and negative for anti-clockwise, and we fill the result in table 3.3. And so we set the input angle 5, positive 5 for clockwise, and again 1. For input voltage, shaft motor position and output voltage, and then we change to clockwise, which is change to negative, and we run the simulation. We can see that the value for input voltage, shaft motor position and output voltage in negative values. Then we will repeat for 150 clockwise, anti-clockwise, and then 360 clockwise and anti-clockwise, and we will record the value for input voltage, output voltage and shaft motor position in table 3.3. That's all from me. Thank you.